I'd like to start out by thanking you very much for bringing me across from Adelaide to Queensland. It's always a wonderful journey to make. I do have some emotional attachment to Queensland because I actually own one of your old railway carriages, which I'm restoring as a holiday home. If ever any of you are in Adelaide, do come and visit the St Kilda Tramway Museum, where she's sitting very proudly. The Grand Challenge lecture series is a wonderful title, wonderful idea, because what I want to talk about within science are, I think, the greatest challenges that we've ever faced. They are challenges which have been identified by science, they are challenges which have been described by science, and they are challenges that science can actually give us some clues as to how we can go about addressing those challenges. We're looking into the future and the confluence of a number of pressures that are coming to bear. And we really do need to seriously ask the question, can humanity survive the combined effects of climate change, population growth, and resource use? Now, I just want to go through those individually and then bring it all together at the end of the lecture. I think most of us are aware of what climate change is. This is the nub of the problem, that in the carbon cycle of the world, we are adding something close to 30 gigatons of carbon to the carbon cycle, carbon dioxide into the atmosphere each year. And that is not being absorbed into the cycle, so it's accumulating. It's a greenhouse gas, so it traps heat in the Earth, warming the planet. We know the history of carbon dioxide in the atmosphere going back 400,000 years, and here you can see that in the last couple of hundred years, we've gone radically above the background fluctuations in atmospheric carbon dioxide. The peaks you can see in this area going in the past, they are interglacials, and the troughs are glaciations. So this is a number of ice ages. So carbon dioxide concentration is high historically. If we go to a more immediate timescale, just the last 50 years or so, you can see that there has been a continual increase in atmospheric carbon dioxide. The red line wiggles up and down. It's basically the breadth of the northern hemisphere carbon cycle, so that in spring and summer, as plants are growing, they're absorbing carbon dioxide. As we go into the winter and autumn, they're shedding carbon dioxide. So you get this breathing pulse, but the overall trend is a definite and continuous increase. If you actually then combine that to the effect on temperature, again, here we're going back 800,000 years. You can see the pulses up and down of the glacial and interglacial periods, and carbon dioxide concentration and temperature are pretty much in lockstep over the last 800,000 years. If you bring those two together over a more immediate timescale, over the last 100 or so years, you see that there is also a very good fit between increase in temperature and increase in carbon dioxide. Quite often, when you put this up, someone might say, well, you've got a correlation, and correlation doesn't necessarily mean causation, and they're correct. But the other side of that is the fact that you can't have causation without correlation, and that if there is a causal effect that you've identified, and carbon dioxide as a greenhouse gas was identified over 100 years ago, then you should be able to go out and find a correlation between carbon dioxide concentration in the atmosphere and temperature. That's exactly what the data shows. What's going on here? So, if we look at temperature over the last 1,000 years, again, you can see that within the last 200 years, particularly within the last 50 years, carbon dioxide levels have risen way above the historical range for temperature. Going back to a tighter time scale, you can see that several different methods of measuring temperature over the last 100 or so years are pretty much in agreement as to that increase in temperature over that period. So climate change is real. And something that's worrying, last year was the first time that carbon dioxide concentrations got to 400 parts per million in the atmosphere. Last month was the first month where they didn't drop below 400 parts per million for the whole month. So this is an ongoing problem, and it is a real effect. There are already impacts from climate change. We know that sea levels over the last century have risen somewhere in the vicinity of 17 centimetres. The number of people have said, well, it hasn't risen 17 centimetres in my backyard. That's because this is a global average. And while you might think that there could be a global rise and everything goes up by the same amount, it's not that simple. But the calculated tidal rise is 17 centimetres over the last century. The global temperature rise over the last century, the global temperature has gone up by around 1 degree. Most of that warming has been since the 1970s. The warmest 20 years have occurred since 1981. And all 10 of the warmest years on record have occurred within the last 12 years. So this is, again, confirmation that this is actually happening. The world is warming. There are more extreme events occurring around the world. The glaciers are in retreat on all continents. There are 1 or 2 glaciers that are not in retreat, but most glaciers by far are actually in retreat and have been for at least the last century. The ice sheets in the Arctic are shrinking quite dramatically. Sorry, the continental ice sheets are shrinking. Greenland lost something between 150 and 200 cubic kilometres of ice per year from 2002 to 2006. Antarctica's lost something around about 152 cubic kilometres a year over a similar period. There are declining sea ice in the Arctic, as I was just alluding to. That is a dramatic decrease, and the first Antarctic ice-free Arctic summers are expected within the next 5 years. And the oceans are definitely warming. A lot of this extra heat that's going into the system is actually being captured by the oceans, and the oceans are warming faster and containing more of that heat than the atmosphere. And a particularly worrying trend is that ocean acidification is happening, where the pH is rising because the interaction with a higher increase in carbon dioxide in the atmosphere means that we get a higher pH in the oceans. And in fact, only last week there was a paper put out where we've actually started to measure the effects on ocean acidification, dissolving the shells of pteropods. These are small mollusks that are free-swimming. They are the bottom of the food chain, and if we interfere with them, if that starts to drop away, then we're actually cutting away at the bottom of a large chunk of the oceanic food chain. These are measured impacts. Earlier this year, we had this report come out from the IPCC, which was looking at climate impacts. On a global scale, they measured the fact that precipitation and snowmelt are altering the way that they occur, generally getting drier around the world. Many terrestrial, freshwater and marine species are shifting their geographic ranges in response to climate change. Essentially, they're moving poleward where it's cooler. There are negative impacts of climate change on crop yields, and they've been measured on every continent. The worldwide burden on human health which was expected, is not as great as expected, but they do make the point that we're not measuring the impact on human health of climate change with the fidelity that would be required to nail that relationship. And impacts from climate extremes, such as heat waves, droughts, floods, cyclones, wildfires, are impacting severely on people around the world. Think of the increase in intense fire seasons that we've had in Australia and has occurred in the United States, the increase in summer heat waves. We've just had a couple of corkers over the last couple of years in Adelaide. In fact, it was only earlier this year that on my way home from work, someone was actually cooking an egg on the footpath. It was that hot. Climate-related hazards are greater for people living in poverty. So a lot of the effects of climate change are being felt by the people around the world who are least able to cope with them. Within this report, if you look at Australia, it notes that we have average rising in temperatures and a decrease in rainfall, particularly in southwestern and southern Australia over the last 50 years. They note that the warming is projected to continue through the 21st century for Australia, that we can expect rising snow lines, and this has already been measured that the snow lines are rising in Australia, as well as increased flood risk from more intense rainfall events. The average rainfall is expected to decrease across southern Australia and most of southwestern Australia and most of southern Australia. Tropical cyclones are actually expected to decrease in frequency but increase in intensity. And again, that's been what's happening. We've had fewer cyclones over the last few years than we would expect, but they have been more intense in general. So this is what you would expect under a warming world scenario. Fire weather is projected to increase in most southern Australia, so we will see more extreme fire events. Regional sea level rise is likely to exceed the historical rate in Australia. So it's been in the vicinity of 17 centimetres, which is the global average over the last century. That rate of increase in sea level rise is expected to increase for Australia. And there is a significant reduction in agricultural production in the Murray-Darling Basin in particular, but also across southeastern and southwestern Australia because of the lack of rain. Rain is going to become more infrequent. When it does arrive, it will be more intense. So there's no question that climate change is real. There's no question that it's already having impacts. Because we've been tracking these things, we can then say, well, what does the future hold with respect to climate change? What can we expect to happen over the next couple of decades, half century, century? On a rather long time scale there, we can see that the expectation is that within the next century, we are looking at perhaps as much as 5 degrees temperature rise, more likely around 4 degrees. On a more closely, a finer time scale here, going back to 1900 and going forward to 2100, we can see that the predictions for temperature rise, they're all on the upward stroke. We don't know, the reason why there's variation in those predictions is that we can't predict what we're going to do with respect to mitigating carbon dioxide and other greenhouse factors. But the alarming thing there is that for the world, we are looking at a temperature rise by the end of the century from between 2 degrees up to 5 degrees. And more modern refinements of these predictions do tend to push it towards the upper end of that temperature range. Atmospheric carbon dioxide, again, difficult to predict into the future because we don't know what's going to happen. Are we going to continue business as usual, or are we going to mitigate and try and reduce carbon dioxide getting into the atmosphere? You can see there that the wide variety of scenarios playing out there. The stabilisation, which would be the most preferable one, where it stabilises out at 450 parts per million, that would require we pretty much stop burning all fossil fuels now, and that's not likely to happen. Business as usual model is probably going to put us in towards the orange range of carbon dioxide levels, the higher range. This is a measure of extreme weather events, and again, they are going to increase for the foreseeable future for the next few decades, so that there will be more extreme weather events for us to have to cope with. So the take-home message is we can expect a temperature rise of around 2 degrees by mid-century, perhaps as much as 5, more likely around 4 degrees by the end of the century. And that by 2100, to just summarise those 2 lines in that one comment, those are pretty much locked in. There's not much that we can do about those temperature rises at the moment. What are those impacts? How are they going to translate into the society and the world in which we live? There's not been a lot of work done on that, but this is perhaps one of the most influential reports looking at the societal impacts of climate change, and this comes from 2007. Now, what they did, this is a Centre for Strategic and International Studies. It was a think tank put together not only of climate modellers, but also of strategic planners, of international diplomacy planning, and a number of other areas of social science where they came together to bring this report together. They effectively looked at 3 scenarios. The first one was the expected scenario. This was projections over the next 30 years of climate change as expected, business as usual model. They then had a severe scenario where, in fact, the rate of climate change is worse by some degree than it was in 2007. And again, that was projected out for about 30 years. Their third scenario was a catastrophic scenario. This was planned over 100 years, and it was predicated on the idea that there could be a tipping point which would drive accelerated climate change, such that by the end of the century, we could be looking at a 5.6 degree temperature rise. Now, as I spoke about in those previous couple of slides, this report was 2007, and subsequently the work that has been done modelling the future of carbon dioxide concentrations and climate change, we are already looking at the expected model to be more like the severe model that these guys were working with. So let's just quickly go through what those 3 models revealed. The first model assumed a temperature rise of 1.3 degrees warming by mid-century. That would be accompanied by 23 centimetres of sea level rise. The effects of that would be water scarcity affecting 1.7 billion people. That there would be a change in distribution of a number of infectious diseases, and that 13 million additional people will be at risk of flooding. Sorry, 13 million people, I'll get it right in a minute. 3 million people will be at risk of flooding and crop failure and hunger due to flooding of agricultural land. Now, there was a number of solutions here, but a number of predictions here as to what would the social impacts be of that. Essentially, it's going to drive an inequality in resource distribution. You are going to have people fighting over dwindling arable land and dwindling access to water. There will be large migrations of people away from areas of scarcity of water and arable land. They will be moving to areas, it's more likely could be categorized as a movement from the third world to the first world. And the first world is not going to take too kindly to having to accommodate these large numbers of people moving away from areas of resource poverty. The severe scenario, which is now looking more likely to be the case that will happen, because they were looking at an average temperature warming of 2.6 degrees warming by mid-century. That would mean just over 0.5 metre of sea level rise, and approximately that's over a 30-year time frame. So water scarcity now, under this scenario, would affect 2 billion people. By the middle of the century, that's probably about 1/4 of the world's population. There would be increased burden from malnutrition, diarrheal, cardiorespiratory and infectious diseases because of the resource scarcity. And up to 15 million people will be living, additional people will be living in flood risk. The effects are accumulative on the previous scenario. So when we actually look at the sorts of things they were seeing, we can see that the movement of people, the scramble for resources, particularly arable land and water, will probably lead to regional wars. They will, and the worrying thing is that this will occur in a number of areas where there are nuclear-armed states, and we could see nuclear war break out over dwindling resources because of climate change. If that was the case, then that radically changes the survivability of our whole species. Even a limited nuclear war would put unbearable strain on the Earth's systems, and it's not a particularly pleasant outlook as to who would be able to survive those stresses on the system. If you go to the catastrophic scenario, again, this was to be played out to the end of the century. They were looking at a 5.6 degree warming. That in 2007, that was considered a catastrophic outcome. At the moment, that now appears to be a likely outcome. It would result in 2 meters of sea level rise globally. We would see 3.2 billion people, which would roughly be, by that time, about 1/3 of the world's population, affected by water scarcity. The morbidity and mortality from heat waves, floods and droughts, and approximately 30% less of the world's coastal wetlands would 30% of the world's coastal wetlands would be wiped out. And up to an additional 120 million people at risk of hunger due to crop failure. So again, the previous influences of driving people to division and to war and regional struggles based around resource security would be driven even further. And we would see that effectively rich individuals, rich corporations and rich nations would more or less be pulling up the drawbridge and trying to isolate themselves from the movement of humanity around the place, trying to avoid the worst effects of climate change. So, not a particularly brilliant outlook just on the question of climate change. But we need to consider that there are other pressures that are compound in this problem, the challenges that we are facing in the future. Not least of these are the questions of population. Currently, there are 7.161 billion people on the Earth as of late March 2004. So as of a couple of weeks ago, according to Wikipedia. Of those people, around 1 billion are starving. That means that they do not have enough food such that their life is threatened by the lack of food. 2 billion people are currently malnourished. That means they are not getting enough food to ensure healthy metabolic processes within them. So almost half of the world is not getting enough food. Ironically, 1 billion people are obese in the world today. So 1/7 of the world's population are having too much food. And what this points to is not so much a question of being able to produce enough food for everybody, it's a question of how we distribute those resources. So, now, the calculation is that if we were to have an average lifestyle that meant that we had a much lower resource use than the average Australian, if we had a smaller environmental footprint per person, then the sustainable carrying capacity of the world is 5 billion people. That means that indefinitely people will be able to sustain a population of 5 billion people forever and a day on the resources that are available in the world. Now, if you compare those two notes, you can see that by that criteria, we are already overpopulated by something like 40%. The predictions are that business as usual, if population is allowed to go out into the future, that by the turn of the century, it should top out at about 11 billion people. But there are good reasons to suspect that we're never going to reach that point. Some of you may be familiar with this book. It was brought out in 1972, The Limits of Growth. It was brought out from the Club of Rome project. And basically, it was a set of computer models of human population growth and the use of various resources into the future. And it looked at a couple of different scenarios and modelled what the future would look like by those computer models. Now, 1972 is a pretty old reference, and thank the CSIRO that in 2008, they actually provided an update, a SITREP, an audit report, an audit commission report on the limits of growth. Because by 2008, you had 30 years of data to see how closely the observed behaviour of human population and resource use, how that correlated to the predicted use of resources and human population over that 30-year period. And therefore, we could say with some more confidence as to which of the modelled scenarios are more likely to be correct. The three models that the limits of growth considered were the standard run. This is business as usual, doing what we do, not looking at restricting population, not looking at actively going out there and trying to use technology to mitigate or help support the population as it grows. The second scenario is comprehensive technology. This is where you do actually go and get technology and you bring it into the game to help support a growing population of the world. The third scenario was the stabilised world model. And this is where you combined both technological improvements to help feed and resource the world with social and political measures to restrict population growth so that you didn't just go on reproducing into vast numbers of people on the planet. Looking at some of the models, how they panned out, when looking at population itself, it found that the stabilised world model resulted in, the stabilised world model, which is the blue squares, would result in a stabilized world population of something like 7.5 to 8 billion people worldwide, and they would be able to be maintained for the foreseeable future. But both the other models, the standard run, so the business as usual model, and the technology model, resulted in population collapse in the middle of the century. So in other words, if the effect of having all those people needing all those resources and using those resources means that you come to a crunch in the middle of the century. And the observed data over the 30 years, which are the black circles that you can see there in the middle of that thing, that shows that we're running pretty close to the standard business as usual model. In this case, we're looking at food per capita. Again, the stabilized model does look to be the favored outcome, where we do end up with a world where we can feed each other indefinitely. But both the standard run model, the business as usual model, and the comprehensive technology model both resulted in a collapse of food availability per capita around about the middle of the century. In this case, we're looking at non-renewable resources. This was a bit trickier to work with because, and just going back to the food per capita, again, we're running more closely to the standard run business as usual model than the other two models. In the case of non-renewable resources, it was actually quite difficult to tell how we were tracking because the ways of being able to measure our use of non-renewable resources varied so widely that they took in the two extremes of the different models that were on offer. But the overall consensus of the original report and of the updated report in 2008 was that with the 30-year analysis, we are running on on the standard business as usual scenario, or the standard run scenario. And that does result in a collapse of global systems midway through the 21st century. So we've got 3, 4, maybe 5 decades before the global systems collapse. Oh, how did that get in there? Tomorrow, 2 shows of the science of Doctor Who, brought to you by RiAus and BBC Worldwide, will be here in Brisbane. Do get along. Tomorrow will be the first time I actually get to see the show. It's had rave reviews. We opened in Perth a couple of weekends ago. If you like a bit of Doctor Who, if you like a bit of science, do yourself a favour, as Molly Meldrum said, get along. I might see you there. I was told it's always important to change the gear when enough doom and gloom, change the gear. Ladies and gentlemen, back to the doom and gloom. World food production. The simple question needs to be asked, can we actually produce enough food to feed the world? With the projections of, the population's going to get bigger and bigger, can we feed the world? An interesting paper came out here. This was last year, I believe, looking at forecasting agriculturally driven global environmental change to feed a world by the mid-century. So they're looking at feeding a population of about 9.5 billion people by 2050, would require an extra 10 to the 9 hectares of new arable land. That's an area the size of Canada. And ladies and gentlemen, there is not an area the size of Canada of unutilised arable land available to grow those crops on. So there's simply, and this is pretty much a business as usual. This is assuming that we go along the path of doing what we do in agriculture already. So they also found that there would be dramatic increases in nitrogen and phosphorus runoff, which would have all kinds of other environmental detrimental effects. A different scenario was painted by this paper, where they said, well, let's look at the fact that there's a number of areas, large areas of agricultural land, particularly in developing countries, that is, if you like, underutilised. And perhaps what we can do is we can beef up agriculture in developing countries, and therefore that's how we can feed the world. Okay, let's just go through this scenario. So what they found was that the prediction is in the future, the amount of arable land per person in the world is going to drop. It's going to continue to drop, both in developed countries, in developing countries, and around the world. It's going to be, it's been a continuous decline for the last 50 years. It will continue to decline into the foreseeable future. They found that arable land under permanent crops, past and future, this has increased for the developing world. It has increased for the world in general, and it will continue to increase for both of those. In the developed world, it's actually tailoring off, which is probably due to them reaching some kind of limit as to what they can do with respect to arable land in the developed world. If we look at arable irrigated area, past and future, again, we can see that there is there has already been quite an increase globally. Most of that has come from the developed world, although there is some increase from the developed world. And that in the future, there is some stabilisation that will be going on there. They looked at these and a number of other factors, and they concluded that agricultural production will need to increase by 70%. That's nearly 100% in developed countries by 2050 to feed the world. That also means that they'll be able to do it, and they only need an extra area of arable land about the size of South Africa. So that's a lot smaller than Canada. Are those projected increases needed in land, water use, and yields feasible? Well, they looked at the limits around the world, and they said that yes, they think that there is enough land there to do it. There is enough water. There are possible yield increases that does make this viable. So this appears to be a much more favourable get-out-of-jail-free card when it comes to food production than the previous study that I showed you. But they acknowledge that they do not deal with increased pressures from climate change, from the production of biofuels, or they haven't also included in this model the elimination of existing undernourishment, existing starvation and malnourishment around the world. And the real sting in the tail of this report is that it relies on rolling out agricultural technologies that are high in cost, that are high in use of energy, and high in costs of resources, and that those may simply not be there to make this particular get-out-of-jail-free card work. So will we be able to feed the world by getting technological about it? Probably not. Conclusions, ladies and gentlemen. When we bring climate change, population, and food production together, there are, of course, other factors we could go into, energy and what have you, but just to bring these together at this point, climate change is real. It's already having a negative effect around the globe, and it will continue to do so. We can expect 2 degrees of warming by mid-century, 5 degrees. possibly more likely 4 degrees by the end of the century. This is going to result in the increased loss of arable land and water. In order to, a reaction to that loss of arable land and water will be massive migrations of people and triggering of regional wars over dwindling resources, some of which may go nuclear. Added to that, the fact that the world population, as I said, left unhindered, if you could support it, it will go to 11 billion by the end of the century. It's unlikely that it'll do that because the increase in population and its implications for resource use means that population will collapse sometime around the middle of the century. And the major systems that supports population are what's going to be affected there. That's how that's going to collapse. It's unlikely that we will be able to increase food production to meet the increasing demands of the world's population. And remember, for a sustainable world, we are already overpopulated. So this just magnifies the political and social pressures, and instability will become the norm around the world. The effects combined to suggest that civilization is likely to collapse as well. So the complexity of a society like ours will be difficult, if not impossible, to maintain in a world with the resource scarcity that we are to expect around the middle of this century. Just to sort of back up my arguments, here are some other reports that came to a similar conclusion. This comes from KPMG, the auditing and business company. Their report here from 2009, if I remember rightly, on global trends in resource stress, concludes that by mid-century we are going to see catastrophic collapse of resources around the world. It was part of their publication, this map here with the large blue area of the Murray-Darling Basin showing severe water restrictions should be of concern to all Australians. This report was put out in 2012 by Chief Science Advisor for Her Majesty's Government, Sir John Beddington. And he describes a similar perfect storm scenario, that by 2050 we're going to need a 50% increase in energy around the world. We're going to need a 50% increase in food demand, or we're going to see a 50% increase in food demand. We're going to see a 30% increase in water demand, and pushing in the wrong direction on all of those factors is the fact that climate change is there. So it's making it less arable land, less water, and requiring more energy, which is only going to drive more climate change. Another report, this one came out only last week, modelling the use and looking at modelling collapse of global networks and looking at the social instability that will come out of that. Their conclusion is that under the business as usual model that we are currently and have been rolling out for the last several decades, if not century, that under these conditions they find that collapse is difficult to avoid by the middle of the century. Only yesterday, day before, this one came out and endorsed by no less a personage than Barack Obama himself. This is a report on the impacts of climate change in the United States. It concluded that there are definitely there are effects affecting all sectors of the American economy and every area of the United States flowing from climate change. That global climate is projected to continue to change over this century and beyond, but there is still time to do something. And that the findings of this report underscore that it is urgent that we do, in fact, do something if we are to avoid catastrophic collapse. Now, depressing conclusions, the idea that by the middle of this century, the world population will collapse, that civilization probably will not be able to continue, certainly not in the form that we know it at the moment. That is, from the scientific modelling, the most likely scenario to occur. If there's a cheer here, it's not the worst scenario. Meet methane hydrate, or clathrate as it's called. This is essentially just water ice, and inside each little cage of water molecules in the water ice crystal structure is a molecule of methane. Now, these are produced on the sea floor so that as methanogenic bacteria go about their business on the sea floor, the methane that they produce is trapped in the ice and kept locked away there nice and safely. We know of large clathrate deposits in shallow seas all the way around the world. You also get clathrate in the Siberian tundra. We have in more recent years actually seen, as you can see, there's a bubble there. There's a bubble of methane in the tundra. As the tundra's warmed up, it started to release methane. It's found in the tundra of Siberia and across in Alaska and the very north of Canada. So clathrate deposits are estimated, the oceanic clathrate deposits, essentially three times the quantity of methane is locked up in clathrates as all the world's known gas deposits. It's a huge amount of methane. In the tundra, there's another 1,500 billion tonnes of methane locked up. Why am I babbling on about methane? Methane is 21 times more potent as a greenhouse gas than carbon dioxide. So you only have to release a little bit of methane and it can do a lot of damage. It can cause a lot of temperature rise in the atmosphere. In fact, it's been calculated that if all of those, the methane released from those clathrates was to get into the environment, that we could see 5 to 10 degrees warming globally, on top of the 2 to 5 degrees that I've been talking about from carbon dioxide. So we could see, by the turn of the century, 2100, a global temperature rise of 16 degrees. If we went to a global temperature rise of 16 degrees, the only places on the planet that humans could physically live would be parts of Antarctica, the very north of Alaska, very north of Canada, and the very north of Siberia. There simply wouldn't be anywhere else on the planet where we could actually live. Now, should we worry about it? Yeah, because as a paleontologist, I can tell you it's happened before. Back in the Paleocene and Eocene, the little laser pointer's not doing its thing here, sorry. You can see above me here, there's a spike in the temperature record. That's known as the Paleocene-Eocene thermal maximum. And essentially, over a period of about 170,000 years, the global temperatures shot up and remained about 6 degrees above the global average prior to and after it. And we know from isotopic analysis and sediment studies that methane from clathrates was responsible for that rapid temperature rise. What happens is you have enough warming of the seawater due to global warming that warms the clathrate beds up enough for them to release that methane. Now, curiously, when you actually look at the record of extinction on the planet, and that's what you're looking at here. No, go away. Or is it the button on the side? Huh?
Excuse me. This one here, that one at the top.
Oh, that one at the top. Oh, right. Ha, there it is. I must be colourblind. I was expecting a red dot. What this is basically number of species that have gone extinct going back through time by millions of years, so 50 million years, 100 million years. This spike here is the extinction of the dinosaurs, for example. And with the Permian Eocene thermal maximum, there actually wasn't a mass extinction. There were certain groups, whole groups of organisms that disappeared, but there were simultaneously other groups of organisms that flourished. So just because you rapidly warm the world by 6 degrees and leave it there for 170,000 years doesn't necessarily mean you're going to cause mass extinction. But have a look at, no, wrong, go back. That one. This spike here is the greatest mass extinction in history. It's the Permian extinction, about 250 million years ago. That's before the dinosaurs. And the estimates are you've got, well, 55% of all living species. And in order to wipe out 55% of species, you need to wipe out 99.99% of actual organisms that are alive. It was a huge mass extinction, and methane has been shown to be part of the problem. In combination with other factors, we now know that during that mass extinction, temperatures went up by 8 degrees centigrade. So massive thermal shifts, massive temperature rises, are not a good thing from a historical perspective. And we know that there's been at least 2 occasions where these dramatic changes have been triggered by the release of methane from clathrates. Will it happen this time around? Maybe. It might. We have already observed that the rate of methane release from the tundra has dramatically increased over the last decade. And there is some suggestion that clathrates in the Arctic are already starting to release their methane. If we trigger the clathrate gun, we could trigger a mass extinction, and we could see the wiping out of most life on Earth by the end of the century. This might sound like a melodramatic thing to say. Don't bother planning for your grandchildren's future. But it's deliberately melodramatic because that is the time frame that we're talking about. This isn't something that is so far removed from our daily experience, that is so unlikely and so remote. It will happen within a couple of generations, if it happens. As I said, with the clathrate gun, the release of methane, that's not a certainty. The collapse of society, the collapse of civilization under the business as usual model, that is the most likely scenario to occur. So you've got to end these things on a positive note, ladies and gentlemen. These futures are not set in stone. While the collapse of society, of civilization and world populations mid-century is the most likely thing to happen according to our best understandings of the future parameters, it is not set in stone. It doesn't mean it is going to happen. We can act now, and we can do some things that can change that future. What sort of things can we do? First thing, we've got to stop burning fossil fuels, particularly coal. We've got to stop putting carbon dioxide into the atmosphere. If we can wind back carbon dioxide, we're still probably locked in for 2 degrees temperature rise. But if we wind back carbon dioxide now, then that will have a flow-on effect and mean that it's going to be bad, but it won't be as bad as it could be. We need to limit resource use to sustainable levels. I came across a fact the other day that blew my mind. In the north of South Australia, there's an enormous copper mine called Prominent Hill. It puts out something like 700,000 tonnes of copper a year. It's a big copper deposit. It's got a working life of 30 years. We've got FIFO workers flying in and out. It's a big operation. If you could take all of the copper out of that deposit and put it on the world market, it would satisfy world demand for 2 weeks. So we have to find a Prominent Hill copper mine every 2 weeks just to keep up with the current demand for copper. We really have to rethink our use of resources. We have to think about the redistribution of world resources, particularly arable land and water, so that it is more equitable, so that we can diffuse the need for people to migrate across the world or to go to war for access to dwindling arable land and water. We need to restrict population growth. I'm not talking eugenics. Eugenics is not the answer. There's some really interesting modelling that's been done by a colleague of mine in Adelaide called Corey Bradshaw. And he demonstrated that if somehow you could inflict on humanity tomorrow all of the casualties of the First, Second World Wars and the Great Spanish Flu epidemic, it would delay population growth by about 2 years. It would barely be a blip. Eugenics is not the solution. Things like vasectomies and effective contraception and the rollout of those is a good start. But perhaps the best measure for restricting world population growth is to educate young girls. If young girls are empowered and have the knowledge to control their fertility, they will. This has been demonstrated over and over again. And simply educating the young girls of the world could be enough to restrict population growth so that we don't go to catastrophic levels. We should start pre-adapting to a different world. It doesn't matter what we do now. The world is going to be different. We have got temperature rises coming our way that we are not going to get around. We have got population rises. Even if we manage to mitigate against them, there are still going to be population rises. So we need to start thinking about what the world is going to be like in 20, 30, 40, 50, 100 years' time, and we need to start adapting our societies to cope with that. So we need to think more creatively about water collection, capture and storage and distribution. Why are we still having stormwater drains and letting perfectly good rainwater flush out to sea and then struggling through the next drought? We are the lucky country, but that is not the hallmark of a smart country. So there are definitely things we can do to mitigate against a chaotic future. We do need to realise that a chaotic future is the most likely outcome of our present course of action. And perhaps, just perhaps, if we do something now, then we can plan for our grandchildren's future. Thank you very much.